Hello, welcome back. We've recently looked at functions defined by powers and roots, and now we're going to take it into equations and inequalities. Seems like that's kind of the pattern. You know, we hit the functions, then we hit the equations and inequalities. So that's where we're going today. One thing that's going to be very helpful to us as we try to solve these equations and inequalities that involve powers and roots is that let's say you have an algebra equation. You've got algebra expression equals algebra expression. Then you can always raise each side to the same positive integer power and then solve. And when you do, all the solutions for the original equation will be present when you solve. That's something we're going to use as we're trying to deal with equations that have radicals in them, like square roots, cube roots, fourth roots, or fractional powers like 1/3, 2/3, 2/5, 7/9, whatever. The fact that you can raise both sides to the same positive integer power and then solve that resulting equation to find your answers can be immensely helpful. Thing is, though, solving that equation after raising to powers can end up introducing some extra solutions. All of your solutions will be there, but sometimes you have extras too. So it's going to be very important that you go back and check your answers in the original equations. Make sure they work, because you can have extraneous solutions, and if you do, doesn't mean you did anything wrong. In fact, you probably did everything right, but then you got to throw out those extra solutions. And unlike rational equations where it's kind of obvious what you have to throw out based on what would make the denominator 0, here with the radicals, not going to be so obvious. So you're going to have to go back and check. And that's why I am known as the mean professor that makes everybody check stuff on tests. So important here, just warning you. Okay, so let's get down to solving some of these equations, and then after that we'll follow up with solving some of the inequalities. All right, if you've got roots, if you've got radicals, it makes it easier if you isolate one radical on one side of the equation. Even if you have more than one radical, get one of them by itself on one side and get everything else over to the other side. Raise each side of the equation to the integer power that will eliminate your radical, or if you have a rational exponent, eliminate that. If a radical still exists, repeat process, repeat steps 1 and 2. Keep doing that until the radicals are gone. Then solve the resulting equation. Then finally check, check, check. Take each solution, put it back into the original equation, see if it works. If it works, great. It goes in the answer blank. If it doesn't work, throw it out. All right, so here we go with our first question. We are going to take the equation x minus 5 equals square root of 5x minus 1. And we're going to solve for x. Got that equal sign there, so this is an equation. The directions say solve each equation by hand. So that means you're doing it analytically. Do not use a calculator. Or if you really wanted to, you could do it graphically by hand. Don't use a calculator. But analytically is going to be far better, because graphically it'll take some time, and then you run into some frustration sometimes with fractions. So let's do this analytically. All right, first things first. Make sure we have a radical. We have a radical equation here. So we need to make sure a radical is by itself on one side. And that's already here. The square root of 5x minus 1 is all by its lonesome on the right side of the equal sign. So we don't need to get it isolated or anything. It's already all by its lonesome. Okay, so our next step is to acknowledge that it is a square root, and a square root is understood to have an index of 2. So what we're going to do to eliminate the square root is we're going to square both sides of this equation. Because squaring a square root eliminates the square root sign. Because you have a 1/2 power squared, 1/2 times 2 is 1. This is perfectly legal. This resulting equation here, we solve it, it will find all of the solutions to the original problem. Trouble is, it could give us some extra solutions, so we're going to have to make sure we check later. Okay, so x minus 5 quantity squared is x squared minus 10x plus 25. That equals 5x minus 1. Subtract 5x from both sides, and you'll end up with minus 15x. Add 1 to both sides, you'll end up with plus 26. 0. Let's see, have a quadratic equation. And it is factorable because factors of 26 that add to minus 15 include minus 2 and minus 13. So that keeps us in business here. I can take x minus 2, set that equal to 0, and get x equals 2. I can take x minus 13, set that equal to 0, and get x equals 13. All right, 2 potential solutions. Woohoo! Any solutions to this equation are here somewhere, either 2 or 13 or both. We don't know, though, which ones are the solutions. We have to go back and check. 2 and 13 are definitely solutions to x minus 5 squared equals 5x minus 1. We got to go back and check to see which ones are solutions to x minus 5 equals square root of 5x minus 1. All right, so we got to check 2 first. Plug into the original equation with the square root sign in it. You have to use the original because that's what you're testing to see if, make sure you don't have any extraneous solution. Oh boy, I already see that I'm having an extraneous solution here. There's no way for a positive square root to equal a negative number. Oh boy, positive square root of 9 is not going to equal negative 3. So I got to throw out x equals 2. That's not one of my solutions. Okay, what about x equals 13? Yeah, remember, extraneous, throw it out. Okay, now back to 13. 13 minus 5 equals square root of 5 times 13 minus 1. All right, 13 minus 5 is 8. Then I got square root of 65 minus 1, or square root of 64. We're looking at the positive or principal square root. 8 equals 8. Woohoo! That works. So 13 is the solution here to this equation. So there's my answer. That's the only answer. Only it's got that one real answer there. All right, so there's one first example. Next example. Ooh, this one isn't a square root. This one's a cube root. That's okay, we can do this. Cube root of x plus 9, that equals 2. Okay, so first things first, make sure the radical is by itself, and it is. The cube root of x plus 9 is the only thing on the left side of this equation. 2 is over on the right side. So next we're going to eliminate the radical. Since it's a cube root, we're going to cube both sides of this equation. Whatever the index is in that radical, that's what you're going to use as your exponent here. That's the power you're going to raise both sides to. So look carefully at that index. All right, so the cube root and the cube cancel each other out, leaving you with x plus 9 equals 2 cubed, or 8. Subtract 9 from both sides, you get negative 1. Check your answer. Put in the negative 1 into the original problem. Now if you're like, oh, Miss Schofield, I can't have a negative. Actually, you can. Just check it, make sure, see what happens. And it's a cube root, so you can definitely have a negative. Cube root of 8 is 2. Woohoo! This works out. So the solution set for this radical equation includes negative 1. All right, nice. Okay, what do we do if we have one with more than one radical in it? Let's say we have one like this. Square root of 3x plus 4 minus square root 2x minus 4 equals 2. And here's where we really got to think about isolating one of the radicals. We have two radicals, square root of 3x plus 4 and square root of 2x minus 4. Right now those are being subtracted on the same side of the equation, on the left side. So step one is to get one of them isolated. And I think the easiest thing to do here will be to add square root of 2x plus 4 to both sides. So that when I do that, square root of 3x plus 4 will be all by its lonesome on the left. Did I say 2x, square root of 2x minus 4? Yeah. So add that to both sides. So you have the 2 already over there, and now you're adding square root of 2x plus 4. Or 2x, I keep saying that, 2x minus 4. And then that leaves square root of 3x plus 4 by itself. All right. Now, since it is a square root we're dealing with here and that we want to eliminate, we're going to square both sides of the equation. But that means we're squaring the entire side. So this is where it gets a little bit exciting, because you're over on the right side, you're squaring 2 plus the square root of 2x minus 4. So it's not enough to say 2 squared is 4 plus 2x minus square root of the square root and the square cancel, give me 2x minus 4. That's not enough. Keep in mind that 2 plus square root of 2x minus 4, when squared, you're multiplying that whole binomial by itself. So you have to distribute. Or in your case, you're probably thinking FOIL. So yeah, 2 times 2 will give you this 4 here. And the last term, square root of 2x minus 4 times square root of 2x minus 4 will give you 2x minus 4 here. But you have outer and inner, which are going to give you plus twice 2 square roots of 2x minus 4. So plus 4 square roots of 2x minus 4. So you're going to find that you're still stuck with the square root right now. Let's see, 4 and minus 4 will be 0. So you have 2x plus the 4 square roots of 2x minus 4. So this is where the repeating steps 1 and 2 comes in, because you haven't fully eliminated your square roots yet. And that's okay. You haven't done anything wrong. It's just the way it works when you have more than one root to begin with. So what we're going to do is, again, isolate the square root. Get the term that has the square root by itself. So I'm going to subtract 2x from both sides. And I've got 4 square roots of 2x minus 4. I'm just going to leave that on the right side. By getting the 2x over, it's going to make things a lot easier when I proceed to square both sides again. If I had left the 2x on the right, I'd have to again FOIL, and that would again leave me stuck with the square root. But by subtracting 2x from both sides and getting the square root by itself, I will, after this squaring, no longer have a square root in the problem. Because on the right side, I square the 4, get 16, times square root squared leaves me 2x minus 4. Just like that. Distribute the 16. Yeah, it's 4 times the square root. So when I square it, 4 gets squared, square root gets squared, but the results are still being multiplied together. So I have to distribute my 16. All right, subtract 32x from both sides. Subtract 16 from both sides. Let's see, I've got a quadratic equation. Is it factorable? Oh, excuse me. Sorry, it's been a long day. All right. I think about whether or not this is factorable. Thinking, double checking in my head, making sure I did it correctly. I did not do it correctly. I should have added 64 to both sides. Huh? That's like, I know this isn't working right. Sorry about that. If we were in class, you probably would have caught me and corrected me. But we're not in class. No, 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 no. I corrected myself. Okay, so let's do this again. Here, and it's minus 64, you gotta add 64 to both sides. So you should get 80 right there. Sorry about that. Those of you who are watching this. Those of you who printed out the slides, you're gonna have no idea because it's gonna look correct when you print these out. Okay, let's see. Trying to think about factors of 80 that'll add to a minus 24. Minus 4 and minus 20 will work. So let's see here. X minus 4 is 0, and x is 4. X minus 20 is 0, x is 20. Then check them back in the original equation. Let's check the 4. Square root of 3 times 4 plus 4 minus square root of 2 times 4 minus 4. All of that equals 2. So 12 plus 4 is 16. Square root of 16, which is 4, minus, okay, 8 minus 4 is 4. Square root of 4 is 2. And that does indeed equal 2. All right, so 4 checks out. Let's look at 20, see if that checks out. 3 square root of 3 times 20 plus 4 minus square root of 2 times 20 minus 4, and we need to equal 2. So we got 3 times 20 is 60 plus 4. Square root of 64 is 8. Minus 2 times 20 is 40. Minus 4 is 36. Minus square root of 36 is 6. 8 minus 6 is indeed 2. Yay, they both work this time. That does happen. You don't always have extraneous solutions. Sometimes all of your solutions work. So there you go. So you got 4 and 20 for your two solutions there. Cool. All right. Let's see here. Ooh, that looks like fun. 2 more. These are going to be kind of some special cases. This next one's a lot of fun. I like stuff like this. We have the square root of the square root of 2x plus 10. Some of you are probably right now getting mind blown going, you can have that? Yes, you can. And that equals square root of 2x minus 2. It's really no problem. You can have nested square roots, perfectly legal, and you can solve this. It does have a real solution. Let's go ahead and square both sides. Let's see, square the square root on this side, and you're left with what's underneath the radical. So we're underneath the radical is square root of 2x plus 10. Square the square root, we get left with 2x minus 2. But we still have a square root right here, so we're going to square both sides. And then we have 2x plus 10 equals 4x squared minus 8x plus 4. Let's see. Subtract 2x from both sides. Subtract 10 from both sides. All right. I could factor out a 2. Two x squared minus 5x minus 3. What will that factor into? If you want to use your AC method or your guess and check method, either one will work here. I'm looking at if I have a minus 6 on the outside and a plus 1 on the inside, that'll combine and give me minus 5. And plus 1 times minus 3 is minus 3. All right, excellent. Factors. The 2, the GCF out here, is never going to equal 0. and that's okay. It's 2. But the factor of 2x plus 1 has an x in it, so it can equal 0, specifically when x is negative 1/2. Also, the factor x minus 3 can equal 0 when x is 3. So there we go, 2 potential solutions. Go back and check them. All right, let's check the negative 1/2 first. So square root of square root 2 times negative 1/2 plus 10. That has to equal square root of 2 times negative 1/2 minus 2. So on the left side, you got square root of the square root of negative 1 plus 10. So square root of the square root of 9. So square root of 3. Right side, you got square root of negative 1 minus 2. Square root of negative 3. Yikes! Doesn't work. So that's not one of our solutions. That has to get tossed. All right. How about 3? See what happens when we plug that in. Square root of the square root of 2 times 3 plus 10 equals square root of 2 times 3 minus 2. So we got square root of the square root of 6 plus 10 or 16. So square root of 4, which is 2. Right side, you got square root of 6 minus 2. So square root of 4, which is also 2. Checks out. Woohoo! So 3. Solution set has 3 in it. There you go. So 3 is the solution to that crazy radical equation. All right, let's look at one more crazy radical equation before we get into the inequality examples. We've got, actually this is more exponent, 2x to the negative 2 minus x to the negative 1 equals 3. All right, so yeah, remember you're dealing not just with radicals, but also with exponents in this chapter. This problem, you could rewrite it with positive exponents and then handle as a rational equation, which we did earlier in the chapter. So you guys should be equipped to do that. I'll leave that up to you to work on if you want to do it that way. Or use a substitution. Let u equal x to the negative 1. So then u squared would be x to the negative 2. So then we got 2u squared minus u equals 3. 2u squared minus u minus 3 equals 0. Factor. There you go. So 2u minus 3 is 0. 2u is 3. U is 3 halves. If u plus 1 is 0, u is negative 1. But remembering, that's not the answer. U is the same thing as x to the negative 1 or 1 over x. So if 1 over x equals 3 halves, then x would equal 2/3. If 1 over x equals negative 1, then x equals negative 1. Go back, check, make sure it all works. Let's see, let's check negative 1 first. 2 over negative 1 squared minus 1 over negative 1 equals 3. So 2 plus 1 equals 3. Yep, that works. Then 2/3. 2 over 2/3 squared minus 1 over 2/3 equals 3. So 2 over 4/9 equals, or minus, let's see, 3/2 equals 3. 18 over 4, same thing as 9/2 minus 3/2, that's 6/2, which is 3. Checks out. Woohoo! So solution set includes -1 and 2/3. So there you go. So there's a way to do these exponent equations. You can either write it out and handle it as your, in this case, as a rational equation or whatever form comes up. But if it's not familiar to you, like if it converts to radicals or something, it might be a lot easier to use a substitution, like let u equal maybe this middle term, x, and then see what happens when you square that, see if it equals this first term's x, and work from there. That might make things a lot easier. All right. Now, as promised, we'll get into inequalities. We're going to solve the inequalities by examining the graphs on the calculator. So it's going to help to solve the equation first, see where things intersect, and also understand the domain of each radical. Then graph each side of the inequality and look at where everything intersects. So you can either graph y1 and y2 and see where they intersect, see where y1's above y2, see where y1's below y2, depending on whether it's greater than or less than. Or you can do y1 minus y2 and then see where they cross the x-axis and see where they're above or below. Either way. Okay, let's start with this. We have a cluster of problems. We have square root of 2x plus 13 equals 3. We also have square root of 2x plus 13 is greater than 3. And we have square root of 2x plus 13 is less than 3. So we have these three problems, including two inequalities. All right, if we solve the square root of 2x plus 13 by hand, equals 3, we can square both sides, get 2x plus 13 equals 9, 2x equals -4, x equals -2. And if you check, square root of 2 times -2 plus 13, we got square root of -4 plus 13, or square root of 9, which is 3. So that works out. So yeah, x equals -2 is the solution to the equation. But another thing you want to look at is what is the domain of your square root. That's going to be important when you're looking at your graphs, because when you're doing the inequalities, you got to figure out, you got to know where your square root of 2x plus 13 either starts or ends that graph as you're trying to analyze the exact intervals to use in your solutions for the inequalities. So remember, if you have an even index and you want to figure out your domain, you take the radicand and set it greater than or equal to 0. You just don't want inside of here to be negative or less than 0. So 2x is greater than or equal to -13. So x is greater than or equal to -13/2. This is going to be very helpful to know when we go to worry about the inequalities. All right, so let me minimize this and pull up my slideshow, or not my slideshow, this is my slideshow. Pull up my calculator. All right, what I can do is in the y equals, I can put in square root if it cooperates. I'm not sure though, it might have frozen up on me. All right, I'm going to pause. I'll be back. Okay, so we're picking back up. You probably Didn't feel a thing, but I had to pause and do task manager and close down the calculator and start it up again. For some reason it froze. But anyways, okay, I'm at the y equals menu. I'm gonna put square root of 2x plus 13 in. Ooh, I'm also having trouble with my computer lately where it'll like click things that I haven't clicked on. It's been a real problem. I'm not sure why it's doing that. All right, square root of 2x plus 13 for y1. I'm going to put in 3 for y2. Hit graph. There it is. So y1 is this nice curve here. Y2 is this horizontal line here. If I want to see where they intersect, I can go to second trace, which will give me calculate menu, and I can use number 5. First curve, yes. Second curve, yes. Guess, yes. Enter. And they intersect at x equals -2, which does not surprise me in the least, because when I solved the equation, I got x equals -2. Okay, but I need to look at that graph pretty carefully for figuring out what's going on with the inequalities. The first inequality, where is the square root of 2x plus 13 greater than 3? So in other words, where is this curve for square root of 2x plus 13 above the horizontal line for 3? Well, starting at this intersection point, then you see from to the right, from there to infinity, square root of 2x plus 13 is above y equals 3. Now, it's only greater than, so we can't include the point, but we can say that the solution is the interval, open interval, from -2 to infinity. Then for less than 3, that's where the square root curve is underneath that line. The square root curve starts right here at -13/2. So from -13/2, including -13/2, so bracket -13/2, up to this point of intersection at -2, y1 is less than y2. We would not include the -2 because it's only asking for where things are less than. At -2, that's where they're equal. So we wouldn't include it, but we do include the starting point, because from the starting point over to that intersection, all of that piece of the graph is included underneath the horizontal line there. All right, so let me sketch that on here. So we have the graph. We have square root of 2x plus y equals square root of 2x plus 13 looks like this. Starts here at x equals -13/2. Then we have the line for y equals 3. Going through like that. And they intersect right here at x equals -2. Okay, so for square root of 2x plus 13 greater than 3, we have open interval from -2 to infinity. For square root of 2x plus 13 less than 3, we have bracket -13/2, comma, -2 parentheses. Now, if it had been less than equal to or greater than equal to, then you would have used brackets on your -2. That's the difference there. So you use the bracket on -13/2 because that point of the graph is underneath y equals 3. But we use parentheses on -2 because here it was a greater than 3 question. Here it was a less than 3 question. So if there's no equal sign, then we don't want to include -2 because that is where the two are equal or cross each other. Okay, so that's inequalities for you. You'll be able to use your graphing calculator for those. All right, let's do one more set of inequalities. This one's going to involve rational exponents. x minus 3 to the 2/5 power equals 4x to the 1/5 power. And then let's say we have to do x minus 3 to the 2/5 power is greater than or equal to 4x to the 1/5 power. And let's say we have to do x minus 3 to the 2/5 power is less than 4x to the 1/5 power. All right. So 5th power, remember that's basically saying radical index of 5. Basically what you have here is the 5th root of x minus 3 quantity squared equals 5th root of 4x. That's the same thing. So what you can do either way is raise both sides to the 5th power. So you got x minus 3 squared equals 4x, and solve from there. X squared minus 6x plus 9 equals 4x. X squared minus 10x plus 9 equals 0. We got x minus 1, x minus 9 equals 0. X minus 1 equals 0, so x equals 1. X minus 9 is 0, so x is 9. So there's your two solutions to try. You check. 5th root of 1 minus 3 squared should equal 5th root of 4 times 1. So 5th root of negative 2 quantity squared is the 5th root of 4, and that equals the 5th root of 4 times 1, or 4. And then you check 9. 5th root of 9 minus 3 squared equals 5th root of 4 times 9. So you got 5th root of 6 squared, or 5th root of 36. Don't really care what 5th root of 36 is, because I know both sides come out to 5th root of 36, and that's enough for me. I don't need any more than that. All right, I get x equals 1, x equals 9. So for the equals part, solution set includes 1 and 9. Now, since they are 5th roots, it gets kind of interesting because, like, 5th root of 4x, the domain is negative infinity to infinity. And the same thing for 5th root of x minus 3 squared. You're allowed to plug in anything you want for x from negative infinity to infinity, because you can take the 5th root of positive, negative, or 0. So knowing that about your domain helps. When you have that odd index, the domain of your radical is going to be negative infinity to infinity. So you're not going to have to worry about some weird starting points like you did in the previous question. Okay, so let's do the inequality part. Let's put it in the calculator. So we go back to y equals, clear this out. All right, so left side I have x minus 3, and this is raised to the 2/5 power. And right side I have 4x, and that is raised to the 1/5 power. Graph. Interesting. All right, I'm going to change my window a little because I want to get a clearer picture of what's happening here. I'm going to go from negative 3 to maybe 20 and negative 5 to 5. Let me see what that does. just want to kind of look closer at that area where things are intersecting and so forth. I'm not sure that's even going to give me a good picture right now. I can see it kind of right there. I like playing with windows and getting a good view of what's happening. Change that to 4. And let's change that to 4 also. Let's see what happens. Okay, so your Y1 was this bird shaped like a flying bird. Your Y2 is this one here. And looks like I'm not getting in the whole picture now. Ah, silly me. X equals 1, X equals 9. I really do need to go up to 10 in order to really see what's going on. It's kind of hard to see it though. Let's see, let me do 11 and go from there. All right, so that's your y1. That's the x minus 3 to the 2/5 power. And then 4x to the 1/5 power, that's your y2. Yeah. Bear with me, I like playing with windows. Okay, let's put y max at 3. I just really want to get a good feel. Is this going to freeze up on me again? I don't know what the problem is. I've had this program on here quite a long time. Why is it doing this to me? Alright, you know what? I'm gonna pause my recording again and start this over. Okay, once again, I'm back. I went ahead and as I got this back open, I went ahead and set my window and stuff. Ended up settling on x min of -1, x max of 15, and y min of -1, y max of 4. And I feel like that gives me a pretty decent picture. But here you go. The little V-shaped graph, that's your y1 or your x minus 3 to the 2/5 power. And then the sideways, like the S curvy kind of shaped graph, that's your y2 or your 4x to the 1/5 power. The 2 points of intersection are our solutions of 1 and 9. Notice they're both infinite. You know, the V shape goes infinitely to the left, infinitely to the right. The S shape goes infinitely to the left, infinitely to the right. Do it in your calculator, zoom out, you'll see it. And that matches up what we know about domain for these, for fifth roots. So what we got to then do is decide what's going on with the inequalities. First one, where is y1 greater than or equal to y2? Well, y1 is this V shape. So you have to ask yourself, where is this V shape above, greater than, the S shape, y2? And then since it's greater than or equal to, you're going to include those crossing points, those points of intersection. So from way out here to the left, from -infinity until you get to 1, the y1 is above y2. Then for a little while, y1 is below y2 until you get to 9. Then from 9 on, again, y1's above y2. So that's how we're going to determine our inequalities. So let me make this big again, get my pen going. All right, so we have that V shape that goes like this. And then we have that S shape that takes it like that. The V shape is the x minus 3 to the 2/5 power. The S shape is the 4x to the 1/5 power. They intersect at x equals 1 and x equals 9. So those points of intersection are where they're equal. Where is y1 greater than or equal to y2? Well, from -infinity until 1, then picks up again from 9 to infinity. We use brackets around the 1 and the 9 because they're greater than or equals to. If it was just greater than, we would just use parentheses around the 1 and the 9. Where is y1 less than y2? Well, that's between 1 and 9. We use parentheses because it's just a less than, not a less than or equal to. So we just want the stuff here that's below, and that's between 1 and 9. So, and that's it. So there you have it. There's another example of solving inequalities. In this case, it's still radicals. It's just they're written with fractional exponents. All right, well, I hope you enjoyed that. There's a couple of word problems in the assignment as well, but those are mostly a matter of putting things into radical formulas and simplifying. And I think you guys will be able to handle those. But thank you for joining us. Study up, and when you join us again, we're going to be starting a new unit, which should be a lot of fun. All right, take care.